Hello all, welcome to Embedded Linux Learning Point, Linux from Scratch 11.1, Episode 13. Okay, we will start from where we left. In this episode, we start entering chroot and building additional temporary tools. Introduction. This chapter shows how to build the last missing bit of the temporary system, the tools needed by the build machinery of various packages. Now that all the circular dependencies have been resolved, a chroot environment completely isolated from the host operating system except for the running kernel can be used for the build. For proper operation of the isolated environment, some communication with the running kernel must be established. This is done through so-called virtual kernel file system, which must be mounted when entering the chroot environment. You may want to check that they are mounted by issuing find mount. This is the command find mnt. Until section 7.4 entering the ch environment, the command must be run as root with lfs variable set. After entering chroot, all commands are run as root. Fortunately, without access to the OS of the computer you build LFS on. Be careful anyway, as it is easy to destroy the whole LFS system with badly formed commands. Okay, I need to be very careful. Uh, so one thing that is important is the command must be run as root with the LFS variable set. Okay, so here I have running as LFS, not as root. Let's see. All commands are run as root. Fortunately, without access to the OS of the computer you build LFS on. So we should not access the host system OS for uh, building with the root. Okay, changing ownership. Note the commands in the remainder of this book must be performed while logged in as user root and no longer as LFS. No longer user LFS. Also, double check that LFS $LFS or LFS variable is set in root's environment. Currently, the whole directory hierarchy in LFS is owned by user LFS, a user that exists only on the host system. If the directories and files under LFS are kept as they are, they will be owned by the user ID without corresponding account. This is dangerous because a user account created later could get the same user ID and would own all the files under LFS, thus exposing these files to possible malicious manipulations. To address this issue, change the ownership of LFS, all the directories under LFS, to use root by running the following command: chone-r root. And I need to basically come out of the LFS user, switch user to no, directly I can do this. Chone changing the ownership of mount. Okay, let's just check. ls-l to see who is the owner. Okay, now the owner is root. Oh, sorry, not the root. Owner of this is root. User bin. Okay, let's see the case. Okay, now the lsp lib64. Here lib64 is not root. Here, so we change it. Then let's see. Yes, 64 become operation not permitted. Maybe because I need to use sudo. lf is at the sudo user. Okay. Okay, operation not permitted. Okay. It did not succeed because LFS is not the sudo user. So I need to switch back to ELP. So switch user to ELP. Okay, now we are back to ELP. As you can see, ELP is the root user basically. And now let's do this and see if it works. Okay, also I need to do sudo. Okay, now let's just try to. Oh, okay. Now let's see what is the ownership of these directories as L, and you can see okay, everything is owned by root, not an issue. In case if it is not done, let's see paste, and it is sudo here. Okay, so next step is preparing the virtual kernel file system. Various file systems exported by kernel are used to communicate to and from the kernel itself. These file systems are virtual in that no disk space is used for them. The content of the file system resides in memory. Begin by creating directories into which the file system will be mounted. One primary thing which I was supposed to do is the LFS. Okay, the variable is set. So no error. I mean, I didn't commit a big mistake. Okay, now let's begin by creating directories into which the file system will be mounted. Okay, dev proxies and run under LFS. So I will do this command. Okay, its permission is denied. Let me come out of sources. Dot let me there in the make dir sudo. Okay, now it's created. Creating initial device nodes. When the kernel boots the system, it requires the presence of a few device nodes, in particular console and null devices. These device nodes must be created on the hard disk so that they are available before the kernel populates, basically in the dev. And additionally, when Linux is started with init equal to bin bash, creates the device by running the following command. You create the devices by running the following command. So mknode is a kernel creation of the node, basically creating a device. Mknode is normally we use when we want to attach a device driver to the kernel. Okay, probably it needs a permission sudo. Yes, the other command is for the null. Sudo the command. Okay, here it says the default permissions for these devices. Okay, mounting and populating dev. The recommended method of populating the dev directory with devices is to mount a virtual file system such as tmpfs on the dev directory and allow the devices to be created dynamically on that virtual system as they are detected or accessed. Device creation is generally done during the boot process by udev. Since this new system does not yet have udev and has yet to be booted, it is necessary to mount and populate the dev manually. This is accomplished by bind mounting the host system's dev directory. A bind mount is a special type of mount that allows you to create a mirror of a directory or mount point to some other location. Use the following command to achieve this. So here we are mounting dev to LFS dev. So it's a virtual file system. Okay, bound is done. Mounting virtual kernel file system. Now mount the remaining virtual kernel file systems. So we did only for the dev now. Now we'll do for the other directories which are created. Here mount is okay. Here we do dev pts to lfs dev pts. So next command is for this is and the next is for run. tmps to run. Okay. In some host systems, dev shm is symbolic link to run shm. The run tmpfs was mounted above. So in this case, only a directory needs to be created. So here if LFS, if it exists LFS SHM, then you create a directory for a read link for the dev SHM. then entering the chroot. Now that all the packages which are required to build the rest of the needed tools are on the system, it is time to enter the chroot environment to finish installing the remaining temporary tools. This environment will be in use also for installing the final system. As user root, run the following command to enter the environment that is at the moment populated with only temporary tools. Okay, so I don't want to commit a mistake here. So chroot lfs, hope it works. Okay, then what is needed is I need to use sudo to enter the chroot. I have no name. Let me see. The I option gives the environment command will clear all the variables of the chroot environment. After that, only home, term, and ps1 and path variables are set again. The term is equal to hyphen term. Construct will set the term variable inside chroot to the same value outside the chroot. This variable is needed for programs like Vim or less to operate properly. If the other variables are desired, such as C flags or C++, CXX flags, this is a good place to set them again. From this point on, there is no need to use LFS variable anymore because all work will be restricted to LFS file system. This is because bash shell is told that LFS is now the root directory. Notice that the -tools bin is not in the path. This means that the cross toolchain will no longer be used in the chroot environment. Note that bash promptly will say I have no name. This is normal because the etc password of the file has not been created yet. Okay, I got this warning. You see, I have no name and I am in the chroot, LFS chroot. Note, it is important that all the commands throughout the remainder of this chapter and the following chapters are run from within the chroot environment. If you have this environment for any reason, rebooting, for example, ensure that the virtual kernel file systems are mounted as explained in this section 7.3.2 and 7.3.3 and enter chroot again before continuing with the installation. Okay, so what I am using is a virtual machine. They came you with uh, basically a virtual machine where I would be taking a snapshot whenever I am not logged in. So in that way, I keep continuing what I'm doing without uh, doing this again. Okay, creating directories. It is time to create the full structure in the LFS file system. Create some root level directories that are not limited set required in the previous chapters by issuing following command. Note, some of the directories below have already been created earlier with explicit instructions or when installing some packages. They are repeated below for completeness. Okay, created. It's directory. It's created. That's fine. Create the required set of subdirectories below the root level by issuing following command. Okay, for etc under etc we would create opt and sysconfig Under okay, we have lib firmware. Then under media, you have a floppy and CD-ROM. I know it's outdated technology, but I don't say outdated, but we don't use floppies anymore. That's what I know. And make their under user, you have local include source, user source, local include and local source. Okay. And for the user local, we have all these directories, binlib and sbin. And for the user local, you have share, color, dictionary, doc, info, local, locally, and man. All these directories. You see how uh, different directories exist in Linux. Share miscellaneous term info, zone info. Okay, make dir. This is for the man pages. Make dir under var. You have cache, local log, mail, opt, and spool. So under var lib, you have color missing locate. Is locate is created. Yes, if var lib. Okay, fine, it's there. Then you're gonna link the run to var run. Probably yes. Then you're gonna link the var lock to run lock. Install dv and m with the root. Let's see. Okay, creating a directory. Let's do an ls. It created a root directory here. Then install temp and var. It doesn't have temp. Now we're creating temp var temp. Okay, fine. Okay, great. So these are all the directories in the chroot environment. So directories are by default created with permission mode 755. But this is not desirable for all directories. In the command above, two changes are made. One to the home directory of user root and other to the directories for temporary files. This one. Okay. The first mode change ensures that not just anybody can enter the root directory, the same as normal user would do with his or her home directory. The second mode change makes sure that any user can write to the temp and var temp directories but cannot remove another user's file from them. The latter is prohibited by so-called sticky bit, the highest bit, 1 in the 777 bit mask. Okay, FSH compliance note. The directory tree is based on the file system hierarchy available at this. The FSH also specifies the optional existence of some directories such as user local games, user share games. We create only directories that are needed. However, feel free to create these directories. Probably when, let's say, if we want to install some games, we would do it, but not right now. Next section is creating essential files and symlinks. Historically, Linux maintains a list of the mounted file systems in the file etc tab. Modern kernels maintain this list internally and exposes it to user via proc file system. To satisfy utilities that expect the presence of etc lab, create the following symbolic link. So we're creating a symbolic link of proc self modes with etc tab. Create a basic etc hosts files to be referenced in some test suites and in one of Perl's configuration files as well. So here etc hosts, in the host we are just mentioning the local host. The 121.0.1 is a local host IP address. Maybe we can cat, I don't know if it exists. Let's see. etc hosts. Okay, it's there. Cat is there. Okay. In order for user root to be able to log in and for the name root to be recognized, there must be relevant entries in the etc password and etc group files. Create the etc password file by running the following command. Okay, here we cat creates etc password, end of file. Okay, the root, oh, it has this content root x000 root. Okay, so here it is something like it has its own syntax to maintain the passwords. I am not familiar with it, but let's continue. If you want to see, you can just see what it is, etc and password. Okay, the same is stored here. The actual password for root will be set later. Okay, then create etc group file by running the following command. The created groups are not part of any standard. They are groups dedicated, so decided on in part by requirements of the UDEV configuration in Chapter 9, and in parts by common convention employed by a number of existing Linux distributions. In addition, some test suites rely on specific user groups. The Linux standard-based LSP available at this location only recommends that besides the group root with group ID GID of 0, a group bin with a GID of 1 be present. All other groups names and GIDs can be chosen freely by the system administrator, since well-written programs do not depend on GID numbers rather than user group's name. Okay, think it's a root, or the syntax is, I think, what is the user and the permission, then maybe that's the information it has. Some tests in chapter 8 need a regular user, and we add this user here and delete this account at the end of this chapter. Here for the etc password, we are adding tester group instead of tester group. Okay. And we install this tester uh, folder with home tester. To remove the I have no name prompt, start a new shell. Since etc password and groups files have been created, username and group name resolution will now work. Okay. To remove I have no name prompt, start a new shell. Since the etc group files have been created, username and group name resolution will now work. The login, HTTP and init programs and other use number of log files to record information such as who was logged into system and when. However, these programs will not write the log files if they do not already exist. Initialize the log files and give them proper permissions. But before this, what has happened here? Execute user bin bash with the login. Okay, probably I need to do it here. Yes. Now you see, got it root. Fine. Now initialize the log files and give them permissions. Touch. So we are basically creating these files. Change group temp ch group utmp var long. Okay, change the group ch mode. We're just changing the mode. For the btmp also we change the mode. Okay, if you are not aware, 644 is 6 is read write, 0 means it is a file, 6 is read write, 4 is just read, and 4 is just read. So this is the user, sorry, the owner, the user, and the group, the last oh, nibble, last digit. The varlog wtmp file records all logins and logouts. The var log last log file records when each user last logged in. The var log fail log, the file records failed login attempts. The var log btemp records the bad login attempts. You can even check this in our host system, in our host, if it exists. Var log last log. Okay, it doesn't have information. btmp. Okay, it has one log where btmp permission denied. Okay, let's do a sudo. It also doesn't have any information. Okay, from the host. Okay, that's fine. The var log, that's fine. So we just read it. Note: the run utmp file records the users that are currently logged in. This file is created dynamically in the boot scripts. Okay, let's see if this is there. Can't run you user temp. Yes, it has. It says who is logged in. Okay, that's fine. It's elp tty7 run level with the kernel 15.0.47 generic. Okay, some numbers, that's fine, but at least it says who is logged in. Okay, so now that we have the environment ready, from the next episode we start building the packages, or maybe in this it's libstd C++ from gcc pass2. Okay, so that's it for this episode. Please subscribe to this channel. Please leave any feedback or suggestions in the comment below. Thanks for watching.